Draconid Meteor Outburst, presented by Science at NASA. Have you ever felt like the sky is falling? On October 8th, you might be right. Earth is going to plow through a stream of dust from Comet 21P Giacobini-Zinner, and the result could be a storm of Draconid meteors. We're predicting as many as 750 meteors per hour, visible mainly over the Middle East, North Africa, and parts of Europe, says Bill Cook of NASA's Meteoroid Environment Office. Every 6.5 years, more or less, Comet Giacobini-Zinner swings through the inner solar system. With each visit, it lays down a narrow filament of dust, over time forming a network of filaments that Earth encounters every year in early October. Most years, we pass through gaps between filaments, maybe just grazing one or two as we go by, says Cook. Occasionally, though, we hit one nearly head-on, and the fireworks begin. 2011 could be such a year. Forecasters at NASA and elsewhere agree that Earth is heading for 3 or more filaments on October 8th. Multiple encounters should produce a series of variable outbursts beginning around 1600 Universal Time, with the strongest activity between 1900 and 2100 Universal Time. Estimates of the meteor rate range from dozens to hundreds of meteors per hour. One respected forecaster, Paul Weigert of the University of Western Ontario, says the meteor rate could go as high as 1,000 per hour, the definition of a meteor storm. It wouldn't be the first time. Close encounters with dusty filaments produced storms of more than 10,000 draconids per hour in 1933 and 1946, with lesser outbursts in 1985, 1998, and 2005. Meteors from Comet Giacobini-Zinner stream out of the northern constellation Draco, hence their name. Draconids are among the slowest of all meteors, hitting the atmosphere at a relatively leisurely 20 kilometers per second. The slow pace of Draconid meteors minimizes their danger to satellites and spacecraft and makes them visually distinctive. A Draconid gliding leisurely across the sky is a beautiful sight, says Cook. Unfortunately, many of this year's Draconids will go unseen. Glare from the almost full moon will reduce the number of meteors visible over Europe, Africa, and the Middle East by 2 to 10-fold. The situation is even worse in North America, where the shower occurs in broad daylight, from about noon to 5 p.m. Eastern Daylight Time, completely obliterating the display. That isn't stopping a group of high school students from Bishop, California, however. They plan to observe the shower from the stratosphere, where the sky is jet black even at noontime. Led by Science at NASA's Tony Phillips, the 12 students have been launching helium balloons to the edge of space since May of 2011. With more than 95% of Earth's atmosphere below the balloon, the sky above looks almost as black as it would from a spacecraft, perfect for astronomy. The students are going to fly one of our low-light meteor cameras in the payload of their balloon, says Cook. I hope they catch some Draconid fireballs for us to analyze. They could be the only ones we get. Stay tuned for results after October 8th. For more news about things flashing in the night sky, visit science.nasa.gov.
"600 Mysteries in the Night Sky," presented by Science at NASA. The universe is a big place, and there are a lot of things out there that astronomers can't identify. NASA's Fermi Space Telescope has just found about 600 examples. The Fermi team recently released the second catalog of gamma-ray sources detected by their satellite's Large Area Telescope. Of the 1,873 sources found, nearly one-third are complete mysteries. No one knows what they are. Fermi sees gamma rays coming from directions in the sky where there are no obvious objects likely to produce this kind of radiation, says David Thompson, Fermi's deputy project scientist. It's a puzzle. Gamma rays are by their very nature heralds of great energy and violence. They are a super-energetic form of light produced by sources such as black holes and massive exploding stars. Gamma rays are so energetic that ordinary lenses and mirrors do not work. As a result, gamma-ray telescopes can't always get a sharp enough focus to determine exactly where the sources are. And therein lies the mystery. For 2/3 of the new catalog sources, the Fermi scientists can, with at least reasonable certainty, locate a known gamma-ray producing object, such as a pulsar or blazar. But the remaining third, the mystery sources, have the researchers stumped, at least for now, and they are the most tantalizing. Some of the mystery sources could be clouds of dark matter, something that's never been seen before. About 85% of the gravitational mass of the universe is dark matter. The stuff we see makes up the rest. Dark matter is something that pulls on things with the force of its gravity, but can't be detected in any other way. It doesn't shine, doesn't emit or scatter light, hence the name dark matter. Astronomers are not able to detect dark matter directly using optical or radio telescopes, but dark matter just might shine in gamma rays. We've been using Fermi to search for dark matter for a long time, says the principal investigator for the Large Area Telescope, Peter Michelson, of Stanford University. Some researchers believe that when two dark matter antiparticles bump into each other, they will annihilate, producing gamma rays. Concentrated clouds of dark matter could form a gamma ray source at specific wavelengths detectable by Fermi. If we see a bump in the gamma ray spectrum, a narrow spectral line at high energies corresponding to the energy of the annihilating particles, we could be the first to apprehend dark matter, says Michelson. So far, however, the team doesn't have enough data on the mystery sources to confirm or rule out the dark matter hypothesis. Other possibilities include undiscovered pulsars, supernova remnants, and colliding clusters of galaxies. The scientists plan to continue observing until they have some answers. For more news about mysteries in space, dark and otherwise, visit science.nasa.gov. The Sleepy Hollows of Mercury, presented by Science at NASA. The words Sleepy Hollow have been steeped in mystery ever since the 19th century, when Washington Irving wrote about the meeting of Ichabod Crane and the Headless Horseman in a secluded European glen. Of course, that was fiction. On the planet Mercury, the hollows are real. Orbiting Mercury, NASA's Messenger spacecraft has just discovered strange hollows as steeped in mystery as the one Irving wrote about so many years ago. High-resolution images reveal thousands of peculiar depressions at a variety of longitudes and latitudes, ranging in size from 60 feet to more than a mile across and 60 to 120 feet deep. No one knows how they got there. The hollows of Mercury were a major surprise, says David Blewett, science team member from the Johns Hopkins University Applied Physics Laboratory. We've been thinking of Mercury as a relic, a place that's not changing much anymore, but the hollows appear to be much younger than the craters in which they are found, and that means Mercury's surface is still evolving in a surprising way. Mars Reconnaissance Orbiter spotted similar depressions in the carbon dioxide ice at Mars' South Pole, giving that surface a Swiss cheese appearance. But on Mercury, they're found in rock and often have bright interiors and halos. We've never seen anything quite like this on a rocky surface, he says. If you could stand in one of these sleepy hollows on Mercury's surface, you'd find yourself like Ichabod Crane in a quiet, still, haunting place with a jet-black sky above your head. There's essentially no atmosphere on Mercury, says Blewett, so the hollows could not have been carved by wind or rain. Other forces must be at work. As the planet closest to the Sun, Mercury is exposed to fierce heat and extreme space weather. Blewett believes these factors may play a role. A key clue, he says, is that many of the hollows are associated with central mounds or mountains inside Mercury's impact craters. These so-called peak rings are thought to be made of material forced up from the depths by the impact that formed the crater. Excavated material could be unstable when it finds itself suddenly exposed at Mercury's surface. Certain minerals, for example those that contain sulfur and other volatiles, would be easily vaporized by the onslaught of heat, solar wind, and micrometeoroids that Mercury experiences on a daily basis. Messenger has found Mercury unexpectedly rich in sulfur, explains Blewett. Perhaps the sulfur is vaporizing, leaving just the other minerals, and therefore weakening the rock and making it spongier. Then the rock would crumble and erode more readily, forming these depressions. More data from Messenger and further study by the mission's science team could reveal the answer. Meanwhile, Blewett wonders, what other surprises does Mercury hold? The sleepy hollows of the innermost planet may be just the beginning. For more of the mysteries of Mercury and other worlds, visit science.nasa.gov.